Hey everybody, Mr. Rohde here for video 2 on May 7th. We're looking at lesson 34-2 and graphing the sine function. So if you have your unit circle to reference, we'll also reprint it in the book so you can kind of see it and follow along. So only the y coordinates. So we're thinking about the height of the sun over time with this graph. One new goal today, we're going to graph y equals a times sine of b of x, or b times x, I'm sorry, in here. So how do those a and b's affect it, affect the graph? And we're going to identify its period, its midline, and its amplitude, like we did with the generic graphs in the first video. This rectangle. Okay, so on page 515, you'll see that they've taken the values that we had on our unit circle and put them into a table in order to graph the sine function. So you'll notice we're only looking at radians. So your x values, pi over 6, pi over 4, pi over 3, pi over 2, all the common ones we know, along with the ratios that came out. Now again, approximately, 1/2 as a decimal is 0.5, root 2 over 2, a little bit smaller than that, around 0.7, root 3 over 2 around 0.866, and then 1 being that maximum value. You'll notice I've highlighted in red here some really key points. You'll see that we cross 0 3 times, once at 0, once at pi, and once at 2 pi, coming back around. So imagine the sun rising from 0, hitting 0 when it sets, it's on the other side of the world, and then when it comes back around, it's at 0 again. So those 3 key x-intercepts. The maximum at pi over 2, where the sun is at its highest height at pi over 2 of 1. The sine is 1. And then again, when it's at its highest point on the other side of the circle at -1, as we went around that unit circle. So you can see this wave as our thing that we're focused on. And again, if we wind up modifying the sine function, it's going to modify its amplitude and its period, how long it goes, how high it goes. But we're able to kind of identify those key pieces. So again, we're using those unit circle values. Really the zeros, the 1 and the -1 are most important. But we can also fill in these other ones as needed. So again, as we look here, what is the period, midline, and amplitude of the particular sine function? Well, if we start at 0 here, the full waveform is inside of this rectangle. I don't know why I keep going back and forth there, sorry. So if I'm looking at that rectangle, my width is 2 pi. So my period, question 1 here, the period is equal to 2 pi. 2 pi radians, because that's how long it takes the sun to do the full rotation around. Sine to do the full rotation around. Its amplitude is equal to 1. It goes 1 up and 1 down, because the height is 2, and divided by 2 I get 1. And the midline, in this particular case, is y equals 0 for the midline. Now, looking ahead, we won't do this today, but if we wanted to shift the midline, we have to shift the whole function up or down by adding a number to it, which we've done in the past when we've transformed functions. So really, we're looking at this particular piece here and going through it. So why do we know that it repeats every 2 pi radians? Well, let's go back to that idea of coterminal angles. We've seen that if I go negative values, I'm landing on those same values. If I go negative pi over 6, it's the same thing as 11 pi over 6 in the positive direction. So this idea of repeating the same values over and over again by rotating around that circle in both directions is why you get this cyclic or periodic behavior. So now that we've seen the basic sine function and its periodic nature, what happens when we start to put a number in front of it? This a times sine of x, where a is this coefficient. What effect will it have? So we're going to recommend that you use a graphing calculator. You can pause here and use Desmos, or you can use your TI-84. Over here, notice, with the TI-84, you do have to put it in radian mode. I'll show you a quick video using Desmos on graphing these 3 different sine functions that I'll insert in here, and then we'll copy a picture over to look and analyze what changed when this value of a changed. Keyboard here, type. Okay, so here we are on Desmos. In terms of hitting the wrench here, you'll want to make sure that radians is selected when we're graphing trig functions. For the x values, I highly recommend going from negative pi over 6 to 13 pi over 6 by pi over 6s. And again, how do you get that? You just go to the keyboard here, type pi, or actually negative pi. So I need the negative symbol. type pi, it automatically turns in, and then divide by 6, and then you can get the others from there. -4 to 4 on the y. And when you go to type in y equals sine, y equals, you can either type sine with the keyboard or under the functions menu. All of your trig functions are here, along with additional ones you'll learn about in pre-calculus. So y equals sine of x for our first function. Then the book asks us to put y equals 3 sine x and 1/3 sine x. So we'll go ahead and put those in here. Notice I can type it, or I can use the function button. So 1/3, click off, functions, sine x. There you go. Okay, so now that we see this graph on Desmos, we can go ahead and understand that the number in front, in this case 3 or 1/3, changes the amplitude of our sine graph. So our key point still being 0, 0, the end of the period at 2 pi, the middle of the period of pi, a maximum that's going to be pi over 2, or a quarter of the period. And again, at 3 pi over 2, another minimum. Again, that's halfway between the middle and the end, or 3/4 of the period. So those are going to be really key points for later on. So how can we graph different functions with different amplitudes? Very simply, create a graph that goes from 0 to 2 pi or longer. 0 to 2 pi to get at least one period. Sorry, 0 to 2 pi to get one period or cycle in. And then you put your 0 points at the start, at the end, the midpoint. At a quarter, you put your max, and at 3/4, you put your minimum, and you can connect it with this nice smooth curve, as you see in the graph here. So let's try that together. So here's a couple examples: 2 sine x, half sine x, and -1 sine x. Again, I went and made my graph. I went by halves on the y's, and from 0 to 2 pi, I know that important things are happening at the pi over 2 values for the max and the mins. So I have to go at least by pi over 2 everyone. I went by pi over 4, just half of that to make it even more spread out. So I know at the start I'm at 0, at the end of 2 pi, I'm at 0, halfway between, I'm at pi, and then halfway between there is my max. My max now is going to be at 2 because my amplitude is 2. My period for all of these is 2 pi. And then here, halfway between there, I'm going to be at -2. And I can connect this not with a sharp jagged line, but with a nice smooth curve. And of course, this waveform would repeat over and over and over again. You can go ahead and add in those arrows to help there. Let's take it to the next one. Same exact picture, except now my max and mins are at positive half and negative half. So that would be here and here. And I can connect those with a nice smooth wave. And if you want to put the original sine graph on for comparison, that would be here, here, and here. Here it got bigger. Here it got smaller. And then finally, more interesting, the -1 sine x. Still going through 0. But this whole thing, the amplitude actually is still 1. Amplitude is always positive. Period's still 2 pi. But because it's negative, it's been reflected, meaning instead of going to a max right away, it's actually going to go to a min. So instead of going up to 1, it's going to go down to -1. And then the max will be where the min is. So it's been completely reflected about the x-axis. So again, all of our transformation stuff we've done before, and here's the original sine graph, has been leading up to this point. Okay? And then going in reverse, if I have a sine function with a period of 2 pi and an amplitude of 4, that's just y equals 4 sine x. The amplitude is right there in the front. Midline is not moved. We'll move those next week for how do we shift things up and down. Okay, so we're picking it up here on page 517, where now they ask us to investigate sine x, sine of 3x, inside of 1/3 x. So now the number is inside the trig function. How does that change our graph? So again, pause, graph those on Desmos or your TI-84 to see what they look like. But as you look at my picture down here, you'll notice the black sine function still has a period of 0 to 2 pi. So it looks like the amplitude's all the same, the midline's all the same as I look at those. So actually, if I put that The black one has a period of 0 to 2 pi, as expected. The red one is sine of 3x. That's much shorter, actually. Its period looks smaller. So the periods got smaller. How many cycles happened got smaller. And the blue one is much bigger. Its period is actually 6 pi all the way out here. So 1/3 turned into a period of 6 pi. So how did that happen? So let's take a look at what the book says. Amplitudes and midlines are the same, but the length of their cycles are the same. So it has sine of 3x actually has 3 cycles within 2 pi. So 2 pi divided by 3. One cycle is 2 pi over 3 because there's 3 cycles in a total of 2 pi. Meanwhile, the 1/3 x, that means 1/3 of the cycle is in 2 pi. So to get a full cycle, I'm going to need 3 of those. So 3 times 2 pi would be 6 pi. And so it's 6 pi for that whole cycle. What that creates is this formula that says whatever number is in here for the b, 2 pi divided by b is going to create our cycle length, so how wide it is, and then we're going to be able to plot those critical points at 0 at the start, middle, and end, and our max and mins at the 1/4 and 3/4 points. Okay, so let's take a look at how the book does that and try a couple together. So 2 pi divided by b is the big takeaway from this section. That's going to change our period or our wavelength. Okay, so here's page 518, where they're just modifying the period here. B is 2/3, so 2 pi divided by 2/3 is 2 pi times 3/2. That becomes a period of 3 pi. Generally, you want to look at the quarters of your period. So 1/4 would equal 3 pi over 4. So that means I'm probably going to do all of my tick marks by a minimum of pi over 4 for tick marks. And my amplitudes is still equal to 1 here because that's the number in front. And so you can see here they did every pi over 4. So at 0 and then at 3 pi over 4, or sorry, 0 and 3 pi, they put their zeros. What's halfway between there? 3 pi over 2. Halfway between 3 pi over 2 and 0 is 3 pi over 4, so that's my max of 1. My minimum of -1 is at 9 pi over 4. Exactly symmetrical, connect it with a waveform. So all we're doing is figuring out what we have to do our tick marks on, still making our 5 critical points. Looking down here, sine of 4x. So 2 pi divided by 4 tells me my period is pi over 2, so I have to do at least 1/4 of pi over 2, so that's pi over 8 for tick marks. They might go smaller than that. So pi over 8, 2 pi over 8 is pi over 4, 3 pi over 8, 4 pi over 8 is 4 pi over 2. So the whole thing from 0 to pi over 2, point, middle is another 0. Halfway between these first two is our max at 1. Halfway between the second two is our minimum at -1, connecting it with a smooth curve. The original one goes from 0 to 2 pi, so we get to compare it there about how much smaller that period is. Let's try a couple of these together. Okay, so try these B and C. We notice here our amplitude, of course, is going to be 1. So I'm just going to label our y-axis by halves so I can get to 1 there. And then our period is 2 pi over b. So in this case, 2 pi over 2. Our period is pi. So I want my tick marks to be at every 1/4 pi because at least 1/4 of the period or less. So pi over 4, 2 pi over 4 would be pi over 2, 3 pi over 4, pi. 1, 2, 3, 4, this would be 2 pi, right? And so as I look at those, how do I go about graphing this? The whole period is within pi, so I've got to start at 0, end at pi. The middle is again at 0. The max is halfway between those. The min is halfway between those. And I get that as that. If I wanted to repeat it again, I could. Exact same pattern. And if I want to draw the original sine of x graph, because I know that goes from 0 to 2 pi, 0 in the middle, max there, min there, and I am good to go. Oops. That minimum is actually 1 more over. And let's take a look at the next one. So in this case, again, my amplitude is 1, so I'll put 1, -1. My period is 2 pi divided by 1/2, so that's 4 pi. So my tick marks Has to be at least at every pi. I'm going to go ahead and make them at pi over 2 just to spread this out. So pi, 2 pi, 3 pi, 4 pi, 5 pi. So let's go ahead and graph this new one. Whole thing goes through 4 pi. So 0, 0, 4 pi 0, halfway is 2 pi 0. And it's going to be really helpful to actually label all these points as we go forward. So 2 pi comma 0, 4 pi comma 0. We did not do that on the red graph, but you could. 0, 0, the max, pi comma 1, 3 pi comma negative 1. Okay, and you've got that. The original sine graph starts and finishes at 0 to 2 pi, halfway, halfway. And so we can see how it's been spread out a little bit. And I could continue to do that as well. If I wanted to draw multiple cycles. Oops. This one's here. Okay. Again, don't forget, go back. If you need to, label these pi over 4, comma 1, 3 pi over 4, comma negative 1. That's helpful. So how do we go backwards with these? What's the equation of a sine function with a period of, so I know my period is 2 pi divided by b, and I know my period is pi over 3, so these are two fractions. I can cross multiply to solve. I get 6 pi equals b times pi, so divide both sides by pi. B must be 6, so y equals the sine of 6x. My amplitude's 1, so that's why the number in front is 1. Okay, so being able to look at that is really, really key. So again, the difference is if the 2 is in the front, that changes my amplitude to 2. If the 2 is on the inside, that's modifying my period. Again, 2 pi divided by b, 2 pi divided by that number. If the amplitude is between 0 and 1, it's making it smaller, right? Making it smaller. If b is between 0 and 1, 2 pi divided by b, if I'm dividing by a small number, it's actually making the period bigger. So if b is between 0 and 1, my graph's going to get spread out left to right, kind of like stretching out a slinky. Okay, here we are on page 519. I want to point out a couple of things. Amplitude, period. Amplitude is always the positive number here. It may be reflected with a negative, and the period is 2 pi over the b for that a sine bx. So when we're looking over here at numbers 9 and 10, can you recognize those numbers? Yes, the amplitude is 8. The period is 2 pi divided by 1/4. 2 pi times 4. Our period here is 8 pi. On the other side for number 10, our amplitude is our amplitude is positive 1/4, but it has been reflected. Always positive on the amplitude. And our period is 2 pi over 8, or pi over 4. So now we're going to graph things that have changed amplitude and period and put that all together. Here's the example from the book. 3 sine cx, the amplitude is 3. The period, 2 pi over 6, is pi over 3. 1/4 of pi over 3, so times 1/4 would be pi over 12. So I probably need to label this at a minimum at pi over 12s. They did pi over 6s and then just kind of went halfway between 0 and pi over 6. To do that, I would have done by pi over 12s. But again, either way would work with pi over 6s, going by those fractions, and plotting those minimum and maximum points. So let's work a couple together. Okay, so let's look at the hard versions now. Identify our amplitudes, our periods. So my amplitude here is a positive 2, but it has been reflected. And my period is 2 pi divided by 2/3, 2 pi times 3/2. That's 3 pi. So when I think about 1/4 of 3 pi, I'm going to do my tick marks in every pi over 4 to help me here. So that's 1, 2, 3, 4 for pi, because this would be pi over 4. My amplitude's 2, so I'm going to go 1, 2, 1, 2. 1, 2, 3, 4 would be 2 pi. 1, 2, 3, 4 would be 3 pi. I know that's where I'm going to end. So I'm ready to go. So my whole period's 3 pi. So I have to start at 0 and end at 3 pi. Halfway in between, well, count it. That'd be 12, so 6. 1, 2, 3, 4, 5, 6. This is technically 3 pi over 2. Halfway between there is my max and my mins. So I've got 6 spots, so 3 spots here, so that's actually going to be 3 pi over 4, which makes sense. And I'm going to be down to at -2 here because it's been reflected. So I'm going down first on my wave. And then halfway in between here, I'm going to be at +2. And I'm done. And again, if I label this point, I'm going by pi over 4s, remember? So 8 pi over 4, this would be 9 pi over 4. So if I'm labeling these points 9 pi over 4, comma, +2, 3 pi over 4, comma, -2. Okay? 3 pi, comma, 0, 3 pi over 2, comma, 0, and 0, 0. If you want to put the original sine graph there, again, 0 to 2 pi. At pi, it's 0. Pi over 2, it's at +1. 3 pi over 2, it's at -1. So you can see the reflection. You can see it getting wider. You can see it getting taller. All right, let's take a look at this one. Amplitude's 3. Period is 2 pi divided by 3. So what's a quarter of that? So a quarter of that is 2 pi over 12, or pi over 6. So I'm going to make my tick marks every pi over 6. So 1, 2, 3, 4, 5, 6 will give me pi. 1, 2, 3, 4, 5, 6 will give me 2 pi. 2 pi over 6 is 2 pi over, oh, it's pi over 3. Three pi over 6 is pi over 2. 4 pi over 6 is 2 pi over 3. So that's actually where I'm going to stop for my piece here. And then I'm going to go 1, 2, 3 for my amplitude, -1, -2, -3. It's not reflected here. So start at 0, end at 2 pi over 3. What's halfway between that? That's pi over 3. Halfway between that is my maximum at 3. Halfway between these two are my minimums at -3, connected with the smooth curve. Okay, so pi over 3, comma 3, pi over 6, comma 3, pi over 2, comma -3. And if I want to, I could repeat this, right? So I know it's going to be at the max again, the min, or the 0, the min, and back up. That would be at 4 pi over 3, comma 0. Because again, it's another cycle. And if I wanted to draw the original sine graph in black, 0, 2 pi, pi, pi over 2, it's at 1, 3 pi over 2, that's going to be down here, it would be at -1. So it would be a nice smooth curve like this. Okay. Feel free to pause, try these on your own, and rock and roll from there. So amplitude, quarter, and then check your answers. Period equals 2 pi over 4, so pi over 2. So my tick marks are going to be at every pi over 8. And I'll put 1 here and -1 here to go by a quarter for my amplitudes. Pi over 8, pi over 4, pi over 2, pi. I go from 0 to pi over 2. That's my whole thing. Halfway between them at 0 again. Halfway between that, I'm at the max of a quarter. Halfway between that, at the min at a -quarter. So again, I get pi over 8, comma 1. This would be 3 pi over 8, comma -1. And if I want to repeat it, I can repeat it as well. So here we go. Sometimes putting 2 cycles down just really helps kind of make it come alive. Okay. And the regular sine graph would go through 1, but I only go through pi, so I'd only get half of the original sine if I was to graph it on there. And over here, amplitude's 1/2. So I'll go by 1 by quarters again. And my period is 2 pi divided by 1/2, so 4 pi. So my tick marks should be every pi, but I'm going to make it just a little bit smaller, going by pi over 2s. So there's 2 pi, 3 pi. It's always to go smaller than you need. It's kind of the minimum, 5 pi. So whole period, 4 pi. 0, 4 pi. Halfway between would be 2 pi. Halfway between that will be my max at 1/2. Halfway between this will be my max at negative half. There is my new graph. So pi comma 1/2, 3 pi comma negative 1/2. If I wanted to do the original sine graph, of course, the original sine graph goes from 0 to 2 pi, with 0 at pi, max at 1, so way up here, max at minimum at negative 1, so this would be the original sine graph compared to my blue sine graph. Okay, so here's that updated word wall with periodic functions. The main thing we added today was this a times sine b of x, that the amplitude is the a in the front, how far it goes up, how far it goes down. If it's negative, it starts with down first because it's been reflected. The period, 2 pi divided by b, whatever that b number is, to stretch it out like a slinky or compress it like a slinky as you're looking at. And the x-axis is always in radians, so starting with a period of 2 pi. All right, let me know if you need any help through email, the office hours. Sorry the first version had no audio, this one should be better.